All right, so it's 1 o'clock. Welcome. This is our first live of the term. So I had displayed an image about how to use Blackboard Collaborate if you haven't used it before. You are not required to turn on your microphone. You are not required to turn on your webcam if you're not comfortable with that. There is a chat feature that you can use. So when I go through this lesson, feel free to ask questions in the chat. If you want, you can ask questions with your microphone, and there's a button to raise your hand as well if you'd like to do that. I record these sessions, and then I will email it out afterwards and post it to YouTube. So that way you can review it later if you want. And all the notes that I write during the session, I also email out as well as a PowerPoint. So that way, if you prefer to just watch and sink in and watch it and then take notes later or use the PowerPoint as notes, you can. Otherwise, you can also take notes at the same time that we're going through here, whatever works best for you, basically. So I will get started by sharing my screen. And if you have any, while we're waiting for the screen to share, if you have any issues, like if it starts to, sometimes you have to refresh the page if you start having issues with it lagging or something like that. I had an issue a couple of days ago where somebody was having some problems and they just had to refresh it and they were good. So just as a heads up. But, that's the nice thing is in the recording, anything you miss, you can go back and watch the recording. So this lesson is on the associative property. If you look in the classroom, in the weekly content, there's a link to my videos, and there's a video link on the left side of the class that's called videos. And for week 2, I have videos for the distributive property, commutative property. I have an overview of all of the properties that you were learning, and then this is going to be just the associative property so that you just see how this property works. So first off, what is mathematical property? So if you've watched my commutative property video, then this is going to be familiar because I introduced it there as well. So a property is a rule or something about something. If you think about you have eye color. We don't really, we'll say that's a trait or something about you. And that's the same thing as like a mathematical property. It's something about the thing that you're talking about. And so an example in math would be squares have 4 sides and they're all the same length. So that's what makes it a mathematical property. So these properties are basically our rules about how algebra works and how math works. And we usually start with the basic rules and then create new rules based off of what we see when we work with the existing rules. That's actually how geometry was created by Euclid. So he decided that he was going to I think there was 3 rules he created with geometry, and then every other theorem and everything is based off of those 3 rules. It comes from there. So that's sort of how math works, is that we find these rules, we mess around with it, see what we can do with it, and then if we find a pattern, that makes a new rule. So the associative property is one of the basic rules that allow us to do a lot of things with math and a lot of things with algebra specifically. So I looked into the history of this rule, and it was named in 1835 by an Irish guy named Sir William Rowan Hamilton. And so he basically, said this is what the rule is, and he called it the associative character of the operation. And so now that's come and become the associative property. So you may be noticing on your discussions this week about the symbols that a lot of our math symbols sort of came about more recently. And the rules that we follow math, those rules came across more recently as well. These were always used, but they weren't actually named until, like the past 400, 500 years. This is where we started actually giving names to these things that we were doing. So if you're wondering, well, why is it called the associative property? I always think it's useful to understand why it has the name it does, because it kind of helps you remember what it does. So if you look up the word associate in the Oxford Dictionary, it means to connect something with something else because they occur together or one produces another. And a lot of these words actually come from usually Latin or Greek. So if you look up the origin of the word, it does come from Latin, which basically means join with a common purpose. So what the associative property does is group things. So we're allowed to group things together. So that's where the meaning of connecting or joining comes in. So that's what the associative property means, and that's why it's called what it's called. So here's what the property looks like in math, in algebra. So if A and B are real numbers, so we're just using letters in place of numbers because they could be any number there, then you can group A plus B together and then add C, and you'll get the same answer if you added B plus C first and then added A. That's what that first rule is saying, is that you can group the first two together, the last two together, and they're equivalent. You'll get the same answer. And this also applies to multiplication, where you can multiply the first two numbers together and then multiply by the third, or you can multiply the last two together and then multiply it by the first one. So the associative property allows you to group addition and multiplication in different ways, and sometimes doing this grouping makes the math easier to do mentally. That's one of the reasons why it exists, is sometimes it's easier to add the last two numbers before you add the first one. So that's what the associative property is. It's just allowing us to group, but it has to be all addition or all multiplication. You cannot mix and match your symbols here, and it does not work with subtraction or division unless you rewrite those as addition and multiplication. So you can't inherently, if you have a whole bunch of things subtracted, subtract them in a different order unless you turn into adding a negative. So these rules apply to addition and multiplication only, but it can make your life easier if you can see, oh, adding these last two is going to be easier on me than adding the first ones. And when you combine it with the commutative property, then you can start rearranging and adding it. If you have a whole bunch of numbers together, you can add them in any order as long as you get them all added. And so those two properties are really powerful for doing math mentally, because you can rearrange the numbers in a way that makes it easier to add up. So you guys are here so you can see how it's used and what it means and like follow the directions and all that kind of thing. So I've got several examples. So for all of these, we're going to be using the associative property to rewrite. So this is important terminology, because with algebra, definitions matter, words matter. You have to know what the associative property is so that you know what you're supposed to do. And you need to know what the word rewrite means versus the simplify versus combine. There's all of these terms. When you see the word rewrite, all that means is that we are using the rule to move the parentheses. We're not adding anything actually together. We're not going to combine any numbers. We're just moving the parentheses. So when you're rewriting, you're just doing one step when you're moving things around. So our rewrite step here for the first one, we have in parentheses x plus 4 plus 9. So we're going to use the associative property to, instead of adding the first two numbers together, or the first two things, because x is not a number, we're going to add the last two. We're going to just move where the parentheses are, and that's the associative property. And the reason why you would want to do that is because you cannot add x plus 4, but you can add 4 plus 9. So that's why we want to be able to move these parentheses, because that way you can actually make things simpler. So we would just rewrite it so that now the parentheses are around the 4 and the 9. So when it says to rewrite, that's all you are doing. You're just literally using the rule by writing it in its other form. Now, if you were told to simplify, so it doesn't actually say simplify, but if you were told to simplify, then you would go for another step and add what you can add together. So 4 plus 9 is 13. So if you were told to simplify, you would say it's x plus 13. You'd actually do that math, do that addition. But this says rewrite, so we are not actually adding the numbers together, we're just writing it in a different form. So it's really, and I didn't even spell simplify right. Simplify, there we go. So it's really important to know the difference between the words and what they mean, because your answer is different based off of what the directions are telling you to do. And something that I see a lot when people are working through the homework, they're like, my answer is wrong, I don't know why it's wrong. And it's often that you are actually doing too much. You're not giving it what it wants. You know, you're doing something, but it's telling you for something very specific, and you're not doing that specific thing that it's saying. So I'm going to do both rewriting and simplify on the right side. So again, you can see the difference, but the rewrite is what we're asking for here. So that's our answer. So on the right, we have our parentheses in the back. So we have -3 plus, and then in parentheses, 5 plus z. So the associative property allows us to move those parentheses, and we can move them to the first two and group the first two things instead. So that would be having the -3 plus 5 in parentheses, and then plus z. Now for your handwriting, I recommend that when you encounter the letter Z, I recommend that you write it the way that I did, with a little line in the middle, so that it doesn't look like the number 2. Because some people write their 2's that way, and then if you write a Z, those could look identical. So I put a line in there so that I know the difference between a 2 and a Z. So you might want to start getting into the habit of doing that for your handwriting when you're doing things with math, so you don't get confused and misread your work. Now, if this problem said to simplify, then we would go one step further and actually add -3 plus 5. So that would give us 2. So our answer would be 2 plus z. But this question says to rewrite, so we are only writing the top part. So that's the rewriting, but simplifying would be then to go and combine those things together that you can actually add. And what we did here is this is using what's the associative property of addition. So the associative property usually has an addition version and a multiplication version, because those are the two things that you can do it with. And so we just write of addition to specify that we use the adding version of the property versus the multiplication version. Are there any questions on either of these two examples? You're welcome to type those in the chat, or if you have no questions, you can type no questions in the chat, and that would be just as fine. Okay, got no questions from one person. Don't see anybody typing anything. So, okay. So here, it's the same thing. We just want to rewrite, and this is going to be multiplication. So I'm going to do the same thing that I did before, where I'm going to show the rewrite step and then the simplify step, so you can see the difference between these two. But it's the same thing. We're just changing where the parentheses are. And the reason why we do this is so we can actually multiply the numbers. Because right now in parentheses, we're multiplying a number times a variable, and those don't multiply because they're two separate things. But if we use the associative property to rewrite it, then we can actually multiply those numbers together and simplify it. So for both of these, all you do is move the parentheses. And when you have negatives in front like these, it does get a little tricky, especially when you've got numbers. So like the first one, I have -5 and then in parentheses 3x. So I don't want to just write -5, 3, and then an x because it looks like -53. And you don't want to use the x symbol for the multiplication because you've already got an x there. So you want to use a dot. And that's how we're going to be indicating multiplication here instead of the letter x, because it would be very confusing if you had an x in there and then the x on the outside, because then you have too many x's. And the same thing on the right. So we have a -12 and then the dot and then the 4. So I just moved the parentheses so that they're the first two numbers instead of the last two things. And then I've got my variable on the outside. And again, I made my z have the line in between so it doesn't get confusing. So those would be, when it says rewrite, that is what it's asking for. It's just making sure that you know what the rule is, and then you can use the rule to rewrite your stuff. Now, if you were told to simplify, that's when you actually do the multiplication. You actually start combining things together that you can. So we would have -5 times 3 for the first example, which is -15, and then you would have an x. And if we were to simplify the one on the right, it would be -12 times 4, which is -48, and then the letter z. So a lot of things that we're doing with algebra, you're going to be told to simplify. And we're going to be multiplying numbers together. We're going to be adding things together. And we use these properties, the associative property, to basically do these things. Any questions on these two? Okay. I can get my slide to move. All right, so I wanted to throw in some that have subtraction and division because, as I said in the beginning, the associative property does not work for subtraction and division. The rule is for adding things and for multiplying, not subtraction and division. But we can make it work. You just have to turn your subtraction into adding a negative. So subtraction is the same as adding a negative. And so then when you do that, all subtraction becomes an adding problem. And then you can use the associative property. And division is multiplying by the reciprocal. That's what we did when we were dividing by fractions, and it works for whole numbers as well. You multiply by the reciprocal. So you can turn a division problem into a multiplication problem as long as you take the reciprocal of what's after the division symbol. And then once you've got a multiplication problem, then you can use the associative property. So we're going to just rewrite these. I'm not going to bother simplifying. We're going to just rewrite. So first, this is going to actually take multiple steps when we rewrite, because first we need to turn the subtraction into adding a negative for this example on the left. So I have my -5 plus 7, and then instead of -2, that becomes adding a -2. And then from there, you can see, okay, I can move my parentheses, and then you can actually rewrite it. -5 plus 7, and then plus -2. And so that would be what it would look like when you rewrite it. So you have to turn that subtraction into adding a negative. Then you move your parentheses. And now the example on the right, we've got inside the parentheses 10 times 5, and then a divided by 2. So we have to turn that division into multiplying by the reciprocal. So what helps is to first turn the 2 into a fraction by writing 2 over 1, because then you can see that what the reciprocal is. So I need to turn the division into multiplication. So that would be multiply, and then I flip the fraction, so that becomes 1 over 2. So we haven't actually used the associative property yet because we haven't actually moved the parentheses. So now that we've turned it into all multiplication, now we can move the parentheses. And that would give us 10 times 5 times 1/2. And that's what it would look like when you use the associative property there. So you want to be careful because you can't just move parentheses with when there's subtraction or division. You need to actually first put it into another form where you can move the parentheses. Are there any questions? Okay. So I've got one last example. I know you guys are probably anxious on a Saturday to go do other things with your family and all that, so I don't want to take up all of your time. So I want to show how you can use the associative property to simplify something with multiple variables. So I've got here 2p plus, and then in parentheses, p minus 5w, and then plus 3w. So currently in parentheses, we have p minus 5w. These are not like terms because they're different letters. You could think of them as apples and oranges. So they're two different things. But I can use the associative property to, instead of grouping the p and the minus 5w together, I can group the p's together. Or you can group the w's together. Or you can group both of them together because you're just moving parentheses. You have things that are added together. You can actually group both of these things together and group them by p's and then group them by w's. But in order to do that, we need to first turn our subtraction into adding a negative. So we've got 2p plus, and then to make things a little easier, instead of the p, I'm going to put a 1p there, because if we have just a single p, and there's one of them, so I can just put that number in front. And then I'm turning that minus 5w into adding a negative 5w, and then I have plus 3w. So far I haven't used the associative property, because I haven't moved the parentheses. I'm just rewriting things so that we can move the parentheses. So I've got my parentheses in the middle between the p and the 5 minus 5w, but I can instead move it to the front, so I can group the 2p and the 1p together. And then I could have minus 5w plus 3w there. And the associative property means you can group things. If it's all added, you can group them any way you want. So I can also group the minus 5w and 3w. That is also allowed with the associative property. You can group as many things together as you want when you have the associative property, as long as they're all adding together or all multiplying. So by grouping things this way, we can see we've grouped the things that are like terms together, and then we just combine them because we want to simplify. So simplify means now you want to also add what you can. So if we have 2p plus 1p, 2 plus 1 is 3. So we have 3p, and then I have my plus sign in the middle. And then a negative 5w plus 3w. So you do negative 5 plus 3, which is negative 2w. And so that is the answer. So we would get 3p plus negative 2w. And I can't simplify further than that because they're different letters, so they're different things. I can't combine them together. So this is as simplified as it gets for this example. Do you guys have any questions? Can it be written as 3p minus 2w? That is an excellent question, and yes. So if you want, you can recombine adding a negative into subtraction. These are equally valid answers, and both would be accepted as your answer. Like in Connect Math, on paper, they're equivalent, so they're both correct answers. So it's up to you which one you prefer to look at. Are there other questions? Okay, so that was my last example. The associative property doesn't take too long to cover, but it is sort of why we're allowed to do what we do in algebra. A lot of people ask, well, why can I do this? This is why. You know, we've got these rules, and this is what allows us to add things together. And then from here, we can start going into solving, and we can do a whole bunch of things. So I'll let you guys go to your Saturday or whatever you're doing. To exit out of this whole system, on the top left, there's 3 horizontal bars. You can click there and then say leave session, or you can just close the window and it will kick you out if you close the window. So whatever is easier for you. And then sometime today, I've got to process the video, upload it to YouTube and everything, and then I will post it in the classroom and email it to everybody, so that way you also have a copy of the recording in case you want to review it. So hopefully this was helpful for you guys. Ones for future weeks are usually going to be longer, most likely an hour, because, you know, we get into harder things, you know, each week we're going to get a little more complicated. So usually these do end up taking an hour, but, you know, because it's recorded, you know, if you can't stay the whole time, that's totally fine. But I'm just going to give you a heads up that these usually will take an hour for future sessions. But all right, well, I will let you guys go. I think I'm going to get a little snack before I start processing the video, and I will talk to you guys later. So thank you for coming. Bye.